Hi, today we are going to continue doing some review material that will help us when we begin chapter 6. And so, like I had mentioned yesterday, today we are really going to review some of these trig identities that we were talking about in chapter 5. So here I've got a whole bunch of the trig identities that we have looked at in the past. Reciprocal identities, remember, our three original trig functions, sine, cosine, tangent, all have reciprocals. Sine deals with cosecant, cosine deals with secant, tangent deals with cotangent. We have a couple of quotient identities. Remember, tangent is the same thing as sine divided by cosine. And so then that means that cotangent is the same thing as cosine divided by sine. We have three different Pythagorean identities. Remember, sine squared plus cosine squared equals 1. And by knowing that, we can manipulate it and get the other two Pythagorean identities. These last ones that are on this slide here, even and odd identities, we haven't really done anything with these yet, but we are going to begin using these. So notice that when you have negative angles, they are going to then help you out with seeing that anytime you have a negative angle with sine, it then becomes the opposite of that sine value. If it's cosine having a negative angle, well, then it just turns into cosine of that angle. The negative goes away. When you're talking about tangent of a negative angle, that becomes negative tangent of the original angle. So notice, and that is very similar then to the reciprocal. Since sine deals with cosecant and sine has a negative that moves to the outside, well, the same thing's going to happen with cosecant. When cosine has a negative angle, it becomes a positive, and so since secant is the reciprocal of cosine, it has the same properties, and then tangent and cotangent relate. So with using these different identities, we are going to look at some of these problems. It says we want to find the exact value of each expression using these identities that I just reviewed with you, and we are not going to be using the calculator at all. So as you can see with this first one, cosecant squared of 2 pi over 7 minus cotangent squared of 2 pi over 7. They have the same angle, 2 pi over 7, and they are squared terms. So the moment I see several squared terms, I want to be thinking about Pythagorean identities. And so the Pythagorean identity that's really going to help us out with this is that 1 plus cotangent squared of x equals cosecant squared of x. Notice that we can manipulate that because cosecant squared minus cotangent squared is what's given. Well, notice that we could very easily just have subtracted cotangent squared over to the other side. That then gives us the only number that is by itself now on the left, which is a 1. So essentially what that problem was is that our x's in this definition is just the angles that are represented here. So that's why it was important to have the same angle when we were dealing with these squared terms, but it was just manipulating that Pythagorean identity. If we look at the second problem, cotangent of pi divided by 7 minus cosine of pi over 7 divided by sine of pi over 7. When I look at that very last term and I see cosine divided by sine, the first thing I'm going to think about is our quotient identity. And so anytime we have cosine divided by sine, that really is the same thing as cotangent. So I'm going to leave that cotangent of pi over 7, that first term as it is, minus, but now I'm going to replace or substitute what this second term is. It's really another cotangent. Notice that both of those angles are pi over 7, which then indicates that we get to continue using that angle of pi over 7. And so by doing that substitution, now cotangent of pi over 7 minus cotangent of pi over 7, since we're subtracting the same thing, it's just going to give us a value of 0. If we continue with this process of finding the exact value using identities and using no calculator, if I look at this next example, cosine of 33 degrees minus cosine of negative 33 degrees, I notice that the second term is dealing with a negative angle. So that means I want us to think about the identity here that when we have a negative angle with cosine, remember that essentially is just the cosine of the positive angle. So I'm going to keep that first term as it is because it's already a positive angle, minus, but now that whole second term is going to be substituted and replaced with what this identity is telling me, which means that it's just becoming now cosine of 33 degrees. So just like the last problem, if I have the same exact thing being subtracted, I'm going to end up getting a value of 0. In the next one, if we have 4 times sine of 24 degrees times the cosecant of 24 degrees. Well, there's 2 trig functions here. They're all being multiplied. Sine and cosecant have a relationship. Remember, they are reciprocals. So essentially, we get to replace cosecant of x, or in this case, cosecant of 24 degrees, as the reciprocal 1 over sine of 24. So we'll have 4 times the sine of 24 degrees times now essentially 1 over the sine of 24 degrees. And because all of this is multiplication and we are multiplying reciprocals, well, 4 then essentially is just being multiplied by the number 1, and 4 times 1 is going to give us 4. And that would be my answer. Really quick, going back to number 3 again, had that subtraction sign in the middle really been addition? Had my problem been the cosine of 33 degrees plus the cosine of negative 33 degrees, we would have then the cosine of 33 degrees plus the cosine of 33 degrees. And so those would be like terms. If you're adding, my final answer would have been 2 times the cosine of 33 degrees. So just realize that subtraction sign allowed us to get a value of 0, but had that been addition, we would just be combining like terms to get a final answer. All right, the last type of identities that I want us to review are those cofunction identities. This is something that we've talked about in the past. Basically, whenever you're dealing with cofunction identities, you are dealing with the complementary angles. So sine and cosine go with one another. However, they have to have angles that are complementary. Tangent and cotangent go together, but their angles have to be complementary. Same thing with secant and cosecant. Now, all of these definitions are in terms of degrees, but as it says, theta could potentially be in radians. And so remember, 90 degrees is the same thing as pi over 2 in radians. So if I wanted us to find a cofunction with the same value as the given expression, once again, no calculator, we will look at the fact that sine of 13 degrees, well, sine's cofunction relates to cosine. And so when we are in degrees, I get to now say that the sine of 13 degrees is the same thing as cosine of 90 degrees minus 13 degrees. So when I subtract those two numbers, I end up getting an answer where the sine of 13 degrees is the same thing as the cosine of 77 degrees. When we want to find cofunctions with tangents, well, remember, tangent deals with cotangent. Remember, I get to technically replace 90 degrees with pi over 2 because I am giving you a value of radians. So we really have cotangent of pi over 2 minus pi over 3. Because those have different denominators, I'm going to find a common denominator. That common denominator would be a 6. So when I multiplied the first fraction, the top and the bottom by 3, that gives me 3 pi over 6. The second fraction, to get that denominator to be 6, I had to multiply the top and bottom by 2. So that's really 2 pi over 6. So notice that now that I have a common denominator, 3 pi over 6 minus 2 pi over 6 gives us pi over 6. So cotangent of pi over 6 would be tangent of pi over 3's cofunction.